Hey everyone, welcome to Tutoring. Hope you're having a great day. Today we are doing a tutorial question which is from chapter 1, question 13 of your special textbook. Alright, so if you haven't watched my topic video for parametric equations, make sure you check that out first before coming over here, because then you'll just be super confused with this. Right, let's get into it. Question 13, we are sketching a graph of these pair of equations, parametric equations. We will just be doing question A because B and C are pretty much just the same, a repeat of question A. We also have to state the domain and the range, very common, of a parametric equation question. Okay, let's get into it. So I'll just write out the pair first. Okay, here's the good news already just by reading this question. 2 pi t, cos and sine. You can straight away use identity rule, no problem, don't even have to do anything special. So if you want to use identity rule, which we know is sine square, I think after doing method 1, 2, this should be ingrained into your mind already, the identity rule. If not, then well, make sure you remember it anyway. Right, so sine square plus cos square equals to 1. And we need to convert these sine and these cos into squares. Before we do that, we need to make those sine and those cos just the subject of the equation. And to do that, we bring everything outside to the left side. So 2 over here, 3 down there, equals to sine 2 pi t, and then we have y minus 4 divided by 2 equals to cos 2 pi t, and then we can just square them. So if I square this, right, the y, I get y minus 4 square divided by 4 equals to cos square 2 pi t, and then we do the same thing for the x minus 2 square divided by 9 equals to sine square 2 pi t. Okay, so once again we have sine square, we have cos square. If you add these two together, we get this equals to 1 right here, identity rule. And of course, it's only logical sense that if we add these two, x minus 2 square over 9 and y minus 4 square over 4, we should also get 1. And there we go. That is our that is our Cartesian equation for this pair of parametric equations. Okay, so we know there's a plus in between the two terms. The denominators are not the same, so it is an ellipse with center 2, 4. A value is square root of 9, that's a 9, excuse my handwriting. And then B is square root of 4, which in this case should equals to 2. It is an ellipse with center 2, 4, A is 3, so that's your horizontal radius is 3, your vertical radius is 2. Okay, here's the trick. You always have to look at the domain, okay? Never forget, don't just randomly draw out a full ellipse. The domain is going to restrict things. And in this domain, it is from 0 to 1 on 4, okay? So I just write the domain here, down here. Domain t belongs to 0 to 1 on 4. Okay, so you can start sketching your graph first. Y, x, and we have a center 2, 4, okay, 2, 4, right there, okay, right, let's sub in points. If you want to see where the particle starts, you can sub in t equals 0 into your original equation, so your pair of parametric equations. So sub in t equals 0 over here, right there, you get 0 inside the bracket for both of them, and x equals to 2 plus 3 sine 0, write it down here so that's easy for you to see. X equals 2 plus 3 sine of 0, and for the y you get 4 plus 2 cos 0, so 4 plus 2 cos of 0. Okay, if you do that, sine 0, make sure you know your trig. Sine 0 is 0, 0 times 3 is 0, plus 2 gives you 2. Cos of 0 is 1, 1 times 2 is 2, 2 plus 4 is indeed 6, right? So where he starts is over here. We know it's x equals to 2, so somewhere along that vertical line. But then y equals to 6, so over here. So this is where the particle starts, at this point. Hey, now you want to sub in 1 on 4 as well. Or if you want to be super really accurate, you can sub in 1 on 8 just to see where he goes. So let's sub in 1 on 4 first, and we can try subbing in 1 and 8 later. Okay, x equals to 2 plus 3. Sub into your original parametric equation again. So that in this case is 2 plus 3 sine 1 on 4 times 2 pi. So 1 on 4 times 2 pi gives us pi on 2. So pi on 2. And you do the same thing for y. Y equals to 4 plus 2 cos pi on 2, because they're the same function. When you sub in 1 and 4, you should get the same number, pi on 2. Right, and then 2 plus 3 sine pi on 2. Sine pi on 2 is 1. 1 times 3 is 3. 3 plus 2 is 5. And then cos pi on 2 is 0. 0 times 2 is 0. 0 plus 4 is 4. So at 1 on 4 second, or 1 on 4 hour, or 1 on 4 minute, he is over here. So 5 and 4. So this point. Okay. So there's only two directions that this particle can move. Either, because it's in an elliptical shape, it can either go from here in that direction right there, or it can go from the start all the other way around and come back over here. So two possible directions. If you want to get clarity on where it is, sub in a point in between, right? I mean, that makes sense. So you can do that over here. So you can sub in 2 plus 3 sine, we can sub in 1 on 8. So t equals to 1 on 8. If you sub in 1 on 8, we get right here. So 1 on 8 times 2 is 1 on 4, 1 on 4 pi. So that's pi on 4. And do the same thing for y. Y is 4 plus 2 cos pi on 4. Alright. Okay, so sine pi on 4 is 1 over root 2. That is 2 plus 3 on root 2. If you expand it, same thing, 4 plus 2 on root 2. You can simplify that, but we know it is in the first quadrant because 2 plus a positive number gives us a positive number. Same thing with the 4. We can make an assumption that when t equals 1 over 8, which is a time between these two values, okay? So this was t equals 0, this was t equals 1 over 4. So in between those two times, he was somewhere in here, in the first quadrant. And it's bigger than 2, so up here, so 2 plus a positive number should give you on the right, a point on the right half of this, so over here. And then 4 plus a positive gives us a point on the top half. So this essentially is somewhere in here. Right, and we can make a logical conclusion that this particle starts here and moves right there, okay? The direction going this way. And that's pretty much it, guys, for this question. You only want to sketch the part of the graph that the particle is moving in, so ignore that dotted line. You shouldn't be sketching it, just erase it out, okay? Aside from that, guys, this is how you do that question. Thanks for watching, and I'll see you in the next video.